Yes, sir. Can.
Okay, sorry, I could not join in time because my computer is not working actually. I don't know. Unfortunately, in the morning I just tried to turn it on, but it's not working on. So I joined from my mobile phone. Okay, let me try to take the class from my phone actually. Okay, how can I share it from it? So can you see my screen?
Yes, sir.
So you're seeing my whole screen, right? Okay. How about now? Can you see it in full screen?
Yes.
Can you see it?
Yes, sir.
Okay, good. So, so in the last class we have been talking impurity measure, right? In this impurity measure, basically we have used these entropy measures, and we have seen that if, in case of binary classification or in case of binary separation, in case of branching, okay, so if we have samples from both of the classes, okay, that means basically we always want to have the samples that belong to one particular class, right? So we have seen that in this case, if the samples are equally probable, okay, that means we have equal number of samples from two classes or multiple classes, what will happen? The impurity measure will be its highest. So we can see in this case, in case of entropy, so basically we see that once we have the probability of class 1, that is P is 0.5, and the probability of class 2, that is the probability is going to be 1 minus P, that is going to be also 0.5, that is when the entropy value will be equal to what? Equal to 1, right? Yes or no? So it's very simple. The entropy value is equal to the summation of the probability times the log of the probability. As you can see in the second equation, it's the summation of the probability times the log of the probability. Is this understood?
Yes, sir.
Okay, you have to respond to me, otherwise I won't be knowing whether you are with me or not. And you can see that there is a minus sign there. Can someone tell me why do we have a minus sign there? So normally we know that if the value is fractional value, because the probability value is a fractional value, it's going to be within the range of 0 to 1. So mostly it is fractional value. So we know that the log fractional value is basically a negative value, right? So that's why if we take a negative at the very beginning, that negative will become positive. So in this case, the impurity value will be, or the entropy value is going to be a positive value. Understood? Okay. So what other impurity tests we have for two? These are specifically, you can see that for two class classification. Okay. So the one other impurity value we have is the Gini index, which is equal to twice the probability of the class 1 and the probability of class 2, that is 1 minus P. Or we can have the misclassification error, which is simply the maximum among the probabilities between two classes or multiple classes, and you just simply subtract it from 1. That will basically give you the impurity measure. That means, let's say if in a particular class all of the samples belongs to, let's say, class 1, what will be the probability of class 1? All the samples, they are from class 1. So what will be the probability of a sample? If you randomly pick, it will be from class 1. What will be the probability?
Always 1.
It will be 1, right?
Yes.
Yes. How about the probability of class 2? It's 0. So what is the maximum value among them? It is 1. And then if I say, what is the impurity value? If you take the misclassification error, what's the impurity value? The impurity value will be 0, right? Because all of them belongs to one particular class. That means your class, that sample set is pure. Can I say like this? Yes or no? Okay. So now the thing is that how do we do the split? Okay, let's say we have found that the model, the node M is not pure. So what should we do? You should divide the samples into its corresponding branches, right? Okay. So we know that in case of, nominal attributes, okay, there are multiple, we have to divide them according to their states. Let's say if the attribute is color and then you have 3 colors, that means you have red, green, blue, then what will happen? You can split them into these 2 corresponding states, right? But in case of a numeric attribute, what can happen? We know that in case of numeric attribute, we can have multiple split positions. Yes or no? Let's say you have 5 values. In case of numeric values, you have 5 values starting from 1 to 5. Then how many split positions will you have? Can someone tell me? Hello, it's a question. Can someone tell me if you have 5 different numeric values, the values are 1, 2, 3, 4, 5, then how many split positions are possible there?
4.
4, right? That means the number can be in between 1 and 2, 2 and 3, 3 and 4, and 4 and 5. That means you will have 4 different split positions, right? Yes or no?
Yes, sir.
Okay. And the thing is that once you want to do a particular split and a particular branch, okay, now the question is that how many attributes can you choose to do the splitting? Let's say if in your feature vector there are n different feature elements, then you reach at a particular node, that means a particular node in that tree, and now if you want to choose, you want to do a split, how many attributes can you choose from to do the split? Is the question clear? So that means if I have n attributes, I can basically choose among n minus 1 different attributes, right? Right or wrong?
Yes, sir.
Okay, because let's say in the previous example, let's say if I go back, okay, let me go back to this figure. Okay, in this figure, once you have you are at the root, and then you have chosen the whether to do the splitting, that means the branching, then you have taken 3 branches, and then let's say once you have reached to the second layer of your tree, let's say if I go to the left hand side of the branch, that means if you have gone the weather state equal to sunny, and once you have reached there, how many different parameter attributes can you choose to do the split? You could have chosen either temperature or humidity or wind. Yes or no? That means how many options did you have? How many options did you have? You had 3 options, right? Yes or no? So do I have to consider the weather again to the second node? What do you think? Yes or no?
No, sir.
No, because already you've considered that in the previous node. So once you go to the next child node, you don't have to consider that particular attribute because you have already considered that one. So how many possibilities will be left to do the splitting? You'll be left with n minus 1 attributes to choose among to do the branching. Yes or no?
Yes.
Okay. So this is basically what we have just I mentioned here. That means the first sub point. That means there are multiple possible attributes on which we can do the split. And again, you know that if the attributes you are picking as a possible attribute to do the split, if it is a numeric attribute, there can be multiple split positions. Okay. Now the thing is that since you have multiple possible attributes, which attribute will you try to pick? You will basically try to pick that particular attribute which will reduce the impurity, because if we can reduce the impurity, we can get a subtree of smaller length. So that's basically the thing. And we know that since this subtree generation is a greedy approach, so this is basically locally optimal, and we have no guarantee of finding the smallest decision tree because it's a greedy approach. Okay, and you know that the tree size is basically measured with the length of the tree or the number of nodes in the tree and the complexity of the decision node. That means how you take the decision at each particular node. But yet finding the smallest decision tree is going to be NP complete. Okay, that means you can basically find it. Okay, you have to just try multiple times and see which one is the smallest one. There are other ways to actually ensure that the decision tree is going to be the small one, but here we'll be simply seeing how do we do the split. Okay, so in this case you can see over here. So let's say you have reached at the node M. Okay. And then you want to pick a particular attribute. Let's say if you choose a particular attribute, let's say that particular attribute was color. If I say like this, so if I say if the color is red, so among n number of samples, some of them will go to the branch, let's say j equal to red. Yes or no? Is this clear?
Yes,
So can you
And then some of the samples will go to the branch, let's say j equal to, for example, green. And some of the samples will go to the branch where the value of j will be equal to green. So if we have n number of samples, you can see that some of them will go to the branch j equal to 1, j equal to 2, and j equal to 3. So if I ask you how many samples went to the branch j, that number is n subscript mj. Is it clear?
yes, sir.
Okay. Now let's say I sorry, I cannot write in my phone now because I don't have this opportunity here. Okay, my computer, hopefully it will start on. I will try to come back to my computer, inshallah. So okay. So basically the thing is, let's say if I have 10 samples, okay, among the 10 samples, 7 of them went to the attribute, let's say red. 2 of them went to the branch with attribute value of green, and 1 of them went to the attribute with blue. So if I ask you what is going to be the value of n subscript j equal to red, what will be the value?
7.
7, right? Yes, because
Yes,
that
sir.
means that particular branch has taken 7 attributes. Okay, fine. Now among those 7 attributes, since we are doing binary classification, okay, among those 7 attributes, 4 of them belong to class 1, that means the yes positive class, and 3 of them belong to the negative class. It can happen, right? Yes or no?
Yes, sir.
Then if I ask you, among all those 7 branches that went to the red branch, how many of them belong to red positive class?
4?
And what will be the probability?
4/7.
4/7, right? Similarly, among 7 samples which went to that red branch, 3 of them belong to the negative class. So the probability is going to be 3/7. So that's why you will see this notation in superscript. Superscript means the number of samples that actually belongs to the ith class. Is this clear? Yes or no?
Yes, sir.
And if I simply say n, what does n means? Though they have written here nm, that means at that particular node m, how many samples in total did you have at that particular node that you wanted to take the decision actually? That's going to be 10, right? Yes or no? So if I say n, so that means I have 10 samples. If I want to say among those 10 samples, the first branch took 7 samples. So that number will be represented by which notation? In subscript j, yes or no?
Yes, sir.
Okay. And among those samples which went to the branch j, how many of them belong to class I? That will be represented by n superscript I subscript j, yes or no?
Yes, sir.
Okay. Okay, now since you have reached to this particular node in M where you have 10 samples, now you have 2 options in your hand. If I go back to this particular example over here. Okay. Now though the decision tree is already done, let's say after doing the split with weather, okay, now you have followed this branch sunny, you have done this branching, and then once you have reached to this particular node, like though it is shown here humidity, but forget about this humidity here. Now let's say I want to take the decision whether I have to do the split with temperature or humidity or wind. So what should you do? You have to choose, right? So if you want to choose, so if I pick humidity, how many possible branches do we have? In case of humidity?
Two branches.
2 branches, right? Now, if I say, that means if I pick let's say at this particular node, how many samples are from Sunny? 1, 2, 1, 2, 3, right? Yes or no?
Yes.
1, 2, 3. Yes. That means once you have reached to this particular node that you see written as humidity, but let's say I don't have humidity here. How many nodes have reached here? 3 of them has reached, right? Yes or no? Now, if you have picked humidity, then basically how many of them will follow the branch high? What do you think?
2.
2, right? Because we can see that the record number 1 and record number 8, they will satisfy that humidity is going to be high. And how many of them will follow the humidity normal?
1.
How many samples? 1. So that means if I look at in this way, that the number of samples in j equal to high, okay, that value will be equal to what? 3, yes or no?
Yes, sir.
And the number of samples taking the branch normal, that means in j equal to normal, that will be equal to what? That will be equal to 1. Yes or no?
Yes, sir.
And once I have, if I take this is my potential way of doing this classification, can I do the same thing for temperature? Can I do the same thing for temperature?
Yes, sir.
I'm taking the possibility. Can I do the same thing for wind? I can do, right? But since you have now 3 possibilities to pick either temperature as a splitting point, to pick among those 3 possibilities, what do you think? What will you do? Of course, you will pick the one which will give you the lowest entropy, right? Yes or no?
Yes, sir.
Is this understood? Now we can see that, let's say if I have picked humidity, and how many samples followed this branch high? You have seen 2. Now if it has followed this branch high, and then you can see that how many samples? 3, or no, so 2. Now what was the probability of playing golf at that branch? What's the probability? Can someone tell me? Can someone mark it for me? Can you annotate for me, someone? Okay, let me say. We are looking at record number 1, record number 3, and record number 8. Now, since we have followed this branch high, that means now we are looking at record number 1 and record number 8. So you can see that both of these 2 records, they follow into which class? To the no class. So what is the probability of playing golf? Okay, let me do it another way. What is the probability of not playing golf?
1/3.
No.
1.
It's 2/2, right? Yes or no? First of all, what is the value of n subscript j equal to high? What is the value? 2. Yes or no?
2. Yes, sir.
And then what do we have here? If I look at here, just keep that numbers in your mind. Okay. Now, if you look at this one, what is the probability of n superscript I equal to not playing golf? What's the value? First, let's have the count. So n subscript j equal to high, you have found 2. Then among those 2 samples, how many of them are saying not play golf?
2.
You had 2, right? Then what is the probability of, that means if the humidity is high, that means you are to play because of the system. What is the not playing golf if the humidity is high? It is 1. Yes or no?
Yes, sir.
Okay. So if I want to compute the the entropy. What is going to be the entropy value? Low, or the entropy value is going to be high? If I look at this equation, sorry, okay. So if one of the probability is 0 and one of the probability is 1, what's the entropy value? Look at the second point. The entropy value is 0. Fine. And if the impurity value is 0, that means the purity is the 100%, right? So that is exactly what you want, yes or no?
Yes, sir.
So do you see what's happening here? So then do we define the branches? And then in this case, what is your leaf branch? Which one are the leaf branch? Do you think humidity is going to be a leaf branch, or is it going to be internal branch? Which one?
Humidity is internal branch.
Internal branch. Fine. And then once you have followed this branch high, you reach to a node, and at that particular node, what is the impurity value? The impurity value is 0. And once you have reached the impurity value of 0, do we need to do any further splitting?
No, sir.
No. And if we don't have to do any further splitting, what do? We level the node with the class level, right? And what class was that one? If the humidity was high?
Not playing golf.
Not playing golf. So similarly, if I follow the normal branch, like I have said, how many samples followed that branch? It was very simple, right? Only one followed that branch. And all the samples, they belong to which class? I mean, only one samples was there though. They belong to which class? To the yes class. So if I compute the probability of yes class, what will be the probability? It will be 1. And following that branch normal, if I compute the probability of not playing golf, what will be the probability? It's going to be 0. So if I compute the entropy, what will be the entropy value? And the entropy value will be again it will be 0. And if it's 0, so it means that we have to a branch. So again, do I have to do any splitting? No. And if I have to do the split, that is I have reached a branch, and then you will label it with what? Yes or no? Which one? It's already given. You're going to label it with yes, right? Is this understood? Is it
Yes,
clear?
sir.
Yes, sir.
Okay. Now, if I move back to the very beginning, okay, I just want to show you this example. I have this at the very end. I just want to show it here. Okay. Let's say at the very beginning, you tried to do the splitting, right? And which one did you pick? You have picked the outlook, whether it is sunny, whether it's rainy, whether it's overcast, something like that, right? Yes or no? So at the very first attribute, like if I just show it here. So at the very first, once you did the splitting, they have used which attribute that they have used for splitting? They have used this weather, right? Yes or no?
Yes.
Okay. So if I move back to this example, it's a similar kind of example. Now the question is that among these 4 attributes, which one will you pick? The outlook, the temperature, the humidity, or the wind? Which one will you pick? You are the root node, remember. Which one will you pick?
Outlook.
Okay. How did you say it's outlook? Because you have seen in the example it was outlook. Yes or no? But if you give it to the computer has to decide. So what will they do? The computer will basically try to compute the entropy for each of the split. First of all, if I want to compute the split using outlook, what will be the entropy value? Do we have to compute? Yes or no? Yes or no? Okay. So if you focus on the outlook, how many states do you have in outlook? Since it's a nominal attribute. How many states do we have? 3. That means what we can do? If I just go over here. So that means if I want to see the entropy for outlook, I will talk about this soon actually. If I want to compute the entropy for following this attribute outlook, and you can see that it has 3 states, one sunny, one overcast, and another is for rainy. Let's compute the entropy for sunny. Can you compute the entropy for sunny? Yes or no? So do you remember the equation? It was the probability times the log of probability and then sum it up all together, right? Okay. Now, if I ask you in this particular example, for sunny, how many, if you follow that branch, how many records are following that branch? You can see that 5 of them are following that branch, 4 of them are following the branch overcast, and 5 of them are following the branch rainy. So if I ask you, the samples which have followed the branch sunny, what's the probability that it has followed the branch sunny?
Five by 14.
5 by 14.
5 by 14, fine. But once you have gone through the branch sunny, how many records have passed? Or how many of them have fulfilled the condition that the overlook is going to be sunny? 5 of them have passed through, yes or no? Now, can you remember that we have to compute that, okay, among these 5 records that have followed the branch sunny, how many of them belong to class yes?
3.
Okay, then what is the probability of class yes for given sunny?
3 by 5.
3 by 5. Okay, and then what is the probability of the negative class given sunny?
2 by 5.
2 by 5.
2 by 5. That's why you can see that once I want to compute the entropy, that means if you follow the branch sunny, if I want to compute the entropy, what's the entropy value? You can see that it's the probability of 3 by 5 log of 3 by 5, then 2 by 5 log of 2 by 5, and then the negative is there, you take the summation, then you have an entropy value of 0.971. Can you see that there? Yes or no?
Yes, sir.
Okay. What is the entropy for rainy? Can I compute in the same way? Yes, sir.
Yes, sir.
That means you can compute the entropy because I can see that probability of yes given rainy is 2 by 5. The probability of no given rainy is 3 by 5. And then accordingly, you can see at the bottom left, you can see the ended up to 0.971. And then if you want to compute the entropy for the branch overcast, you can see that in case of overcast, you can see, do we have an impurity or do we have a purity branch over there? What do we have?
Pure branch.
We have a pure branch, right? That means 4 records have followed the branch overcast and all of them belong to which class? The yes class, right? And that's why once you compute the entropy of the overcast branch, you can see that it has given your impurity value of what? Impurity value of 0. Is this understood? Now the thing is that if I take the split with overlook, if I do that, I want to see what is the entropy for taking the split following outlook. So you can see that this is going to be the equation that we see. So if I want to take the branch outlook, the entropy value for that possible split, this is what I'm saying, listen very carefully. I want to calculate for the attribute overlook, if I want to take the split, and the equation is equal to the probability of sunny times the entropy of sunny, plus the probability of overcast times the entropy of overcast, plus the probability of rainy times the entropy of rainy. So in this slide, what have we calculated? We only calculated the entropies, right? Can we find the probabilities of sunny? Yes or no? Yes, you have already said that the probability of sunny is going to be 5 by 14, overcast is going to be 4 by 14, and rainy is going to be 5 by 14. So can we calculate the entropy of this split? Yes or no?
Yes, sir.
Can we do it? Yes. So if we do this calculation, you can see in this calculation, that means you can see that the probability of sunny times the entropy of sunny, that is 5 by 14 multiplied by 0.971, that's what we have done, plus the entropy of overcast, that is 4 by 14 into the entropy of overcast, that is 0 in this case, plus probability of rainy, that is 5 by 14 times the entropy of rainy, that is 0.97. And if you do this calculation, you'll end up that if I do the split with outlook, what is the probability? Oh, sorry, what is not? It's not the probability. Sorry, what is the entropy? The entropy for this split. What is the entropy?
0.693.
0.693. So this is what you will have if I take the split for outlook. So don't you think you have to do the same thing? That if you take the possibility that if I take temperature at the split attribute, can I do the same calculation? Yes or no?
Yes, sir.
Yes or no? If I take it, if I have taken humidity, can I have a same calculation? Yes. If I take windy, can I have a same calculation? Yes. But if you have calculated the entropy of splitting for outlook, splitting for temperature, splitting for humidity, splitting for windy, but you have to pick one, which one will you pick?
Entropy with lesser value.
You have to pick that particular branch, sorry, that particular attribute with the smallest entropy, yes or no? Right?
Yes, sir.
Okay, what was the entropy for the attribute outlook? It was 0.693. If I do the calculation for the temperature, the entropy value is 0.911. The entropy value, if I calculate for humidity, the entropy value is 0.788. And if I pick the entropy for the windy, entropy value is going to be 892. And if I compare all them together, you can see that I have given you the entropy values for all possible split, for outlook, for temperature, for humidity, and for windy. Which one is giving you the lowest entropy?
Outlook.
Then if that's the case, so if I go back to this particular, sorry, I have to go in the other way around. So I will talk about this information gain soon. Don't worry about this one. So if I, at the root branch, if I want to do the split, which attribute did I pick then?
Outlook.
Outlook. You see, that means whenever you have to do a split, you have to check the possibility of picking among all attributes given at hand. Like you have done in this root node, you have checked outlook, you have checked temperature, you have checked humidity, you have checked windy, you have calculated the entropy for that split, and you have come up with the one with the smallest entropy, that was outlook. Do you see here? Yes or no?
Yes, sir.
Okay. Now, if I ask you, how many samples followed the branch sunny? How many samples followed the branch sunny? Outlook. 5 of them, right? How many of them followed overcast? 4. How many of them followed rainy? 5. Now you can see that if I look at the impurity of overcast, like already I have computed the impurity of overcast here. Here. What was the impurity of overcast? It was 0, right? Yes or no?
Yes, sir.
That means, do I need to do any more further splitting for this particular branch? No. How about if you have followed the branch sunny? What was the impurity value?
0.971.
So do we need to do a split?
Yes, sir.
Yes. In case of rainy, what was the entropy value? 0.971. Do we need to do the split?
Yes.
Yes, sir.
Yes. Like you can see over here, once I look at give you the table over here, you can see that once I have followed this branch sunny, you can see that among the 5 records, 3 of them belong to yes, 2 of them belong to no. So don't you think that you have to further do the splitting over here? Yes or no?
Yes.
Okay. So you can see that in the parent node, you have picked which attribute for splitting? You have picked outlook. So if you follow the branch sunny, and if you have to again, you have to do the split. Don't you think that you have to repeat this process again to compute the possible split, the entropy value for temperature, humidity, and windy, and see which one has the lowest entropy?
Yes, sir.
Yes, sir.
So basically what will happen, this thing will repeat again and again until all the nodes are pure, And if the node is pure, we know that we have reached a leaf node. Like you can see that in case of this branch overcast, what you have reached to a leaf node that is shown in green. Okay, and the class label for that particular node is going to be the one with the highest probability, right? Do you see it now? Yes or no?
Yes, sir.
Okay. So sorry, I could have explained you in more details and with more writing actually. So I had this temporary glitch where I could not. Luckily I did finally turn on my computer just now. Okay. So do you have any questions on this one?
No, sir.
Okay. If I ask you at the very beginning, once I have given you the whole data set, like over here, the whole data set. If I say what is the entropy at the root, but before doing the splitting, can you compute the entropy? Yes or no? That means I haven't done the split yet. I have shown you how to do calculate the entropy for outlook, for temperature, for humidity and windy. But before doing the split, if I say that at the very beginning for this whole data set, what is the entropy value? Can you calculate that one? It's very easy, right?
Yes, sir.
So how many records do we have?
14.
14. Among the 14, how many of them are yes?
9.
9 of them. How many of them are no? 5. So the probability of yes class is going to be 9 by 14 into log of 9 by 14. And for the negative class, the probability is going to be 5 by 14 times the log of 5 by 14. If you sum them up, you will get the entropy value. Yes or no?
Yes, sir.
So before doing the split, you had an entropy value of 0.94. And after you have chosen this particular attribute, outlook, what is the new, sorry, I have to look over here. So where is this one? Yes. Okay, what is the new entropy value after doing the split? 0.693. So don't you think your entropy has reduced? Yes or no?
Yes, sir.
Yes. So if the entropy has reduced because you have done the branching for this particular attribute outlook, that means your data has the tendency of becoming more pure and pure. Yes or no?
Yes, sir.
Yes, sir.
Okay, but if I had picked this temperature, what will be the entropy value? 0.911, right? And what was the previous entropy value? 0.94. So if I pick temperature, don't you think your entropy will also reduce? Yes or no?
Yes.
If I pick humidity, 0.78, also reduced. If I pick windy, it's 0.8, it also reduced. Because that means whenever we are doing the branching for all possible attributes, you will see that your entropy will reduce, but you want to pick which attribute? The attribute with the highest reduction. Yes or no?
Yes, sir.
So you can see that information gain is nothing but computing the difference between the entropy before and the entropy after the split. For example, the entropy before was 0.94. If we do the split with outlook, the entropy is going to be 0.693. What is the difference value? It's 0.247. If I have taken temperature, the difference value is 0.029. If I have taken the difference for humidity, the difference value would have been 0.152. So with which split I have got the highest difference or the highest gain?
Outlook.
Which one? Sorry, we have one more, outlook. So if you want to have more reduction in entropy value, so among all these 4 possibilities, which one I have picked? I have picked the one which has given me the lowest entropy, or in other words, I can say that it will give us the highest information gain. Do you understand this?
Yes, sir.
That means it's easily understood that if the entropy is less, then the difference is going to be higher, right? So it's just inversely proportionate. Yes or no? If you look at temperature, do we have significant difference? Yes or no? So previously it was 0.94. After doing that split with the temperature, it was 0.911. So basically the difference is less, correct? So of course it's going to be a bad choice, yes or no? Though we did reduce it, but we did not reduce significantly. So among all these four, which one reduced significantly? The one with the highest one, that is the one where the attribute is outlook. So that means we'll always pick the one with the lowest entropy or the highest gain. Is this clear? Yes or no?
Yes.
Okay. So do you understand how this this splitting and treat construction will go on?
Yes, sir. Our class, our another
Yeah.
class has already
Yes, I
started. 30.
I will finish it. I will share the link with you. Okay. I will share the link for your attendance later. Okay.
Okay, sir.
Okay. Thank you very much. Any questions? Do you have any questions? No. So if you don't have any questions, thank you for your time and patience. So we'll meet tomorrow for the quiz. Thank you.
Assalamualaikum, sir.